Good morning and welcome back, my dear students. Today we are going to study the language of chemistry for class 7th. Before beginning, I would like to tell you what are the things we are going to study in this chapter. The chapter includes chemical reactions, what are the characteristics of the chemical reactions, and how can we make the chemical equations more informative. So without wasting any time, let us begin. So first topic is chemical reactions. As the definition related to chemistry you are studying from class 6, chemistry is the science of substances and their transformations. So it is a science of substance transform means to change. So in chemistry we study about substances and the change that are occurring in the substances. So when a substance changes to another substance, we say that it is transformed, right? So when one substance changes to the another substance, we say that it is transformed. In fact, we can say that a chemical change or the chemical reaction has taken place. Okay, so what does that mean? In a chemical reaction, okay, there is a transformation of a substance. One substance changes into the another substance, right? So for properly understanding a chemical reaction, we must identify those substances with the help of which we can start and with the help of which we can end, right? So these substances are called as reactants and products. The most important is in a chemical reaction, a reactant is a substance that changes to another substance called as product. Because reactant is that substance with the help of which we can begin our chemical reaction, and product is that substance which has been transformed from a reactant. The change of a reactant to product is represented by a chemical equation. Remember that. So this change of reactant to product is represented by the chemical equation. As I've already shown in the presentation, reactant is changing into product. And remember that in a chemical equation, we mention the reactant on left hand side and products on the right hand side. Very, very important. Reactants are always mentioned on the left hand side and products are always mentioned on the right hand side. Let us move further. Now chemical reactions, they are continued. Now the reactants and products which we are using in any of the chemical equation, they can be represented by their symbols and formulae. That is first, they can be represented by their names in words, or they can be represented by both. All the three examples I've shown in the presentation. For example, here the equation for the reaction between carbon and oxygen, it is written in the following three ways. First way is the representation only by the symbol or the formulae. We know that C stands for carbon, O2 is oxygen. On the right hand side, it gives the product carbon dioxide. So that is the first. Secondly, we can only use the words. Okay, and the third way is by both. We can use the symbol as well as words for representation of the equation. An equation using only words is called the word equation. Remember that. Like the second one, in that we are only using words, so that is called as a word equation. We are going to study about more this type of reaction in the higher classes. Now whenever we talk of a chemical reaction, we know that in any of the chemical reaction, generally two or more reactants, they take part in a chemical reaction. Okay, and they give to form both of them, they react to give a product. It could be two or more products, right? But a chemical, so that chemical reaction in which we have only one reactant that is decomposed to give two or more products, that is called as a decomposition reaction. Okay, so here I've shared the definition. A chemical reaction that involves only one reactant, such reactions are called as decomposition reaction. For example, hydrogen peroxide on being heated, it gives, okay, so reactant is only one, hydrogen peroxide on left hand side. When we are going to heat it up, it is going to give quicklime and carbon dioxide. So the product is 2. The product are 2 and the reactant is only 1. So such is an example of the decomposition reaction. Let us move to the next topic, making chemical equations more informative. To minimize the use of language, we try to make chemical equations more informative. Now here are some of the ways which we are going to discuss, with the help of which we can make our chemical equation more informative. First is mentioning the conditions of a reaction. What do we mean by that? Under what condition the reaction takes place is mentioned on the arrow in a chemical equation. Is that clear? So under what condition your reaction is taking place, that we can mention on the arrow of the chemical equation. Like here as shown in the example, A plus B, where A and B are reactants, they give C plus D as a product, and on the arrow I mentioned the condition 500 degrees Celsius, that is the temperature, and pressure is 8 atmosphere. Okay, so these are the conditions with the help of which we can identify that the reaction takes place under these conditions. The name, symbol or the formula of the catalyst is also sometimes mentioned on the arrow. So sometimes instead of mentioning the temperature or atmospheric conditions, we can also mention the name of the catalyst which is helping for the reaction to occur. Now what is a catalyst? It is a substance that generally speeds up a reaction but itself remains unchanged. That means it helps to speed up the reaction so that the reaction could occur smoothly and easily and fastly. But there occurs no change in the catalyst itself. For example, hydrogen peroxide, it gets slowly converted into water and oxygen if left alone. But if the reaction takes place in the presence of manganese dioxide, it occurs quickly. So here manganese dioxide is a catalyst which is there in the reaction, or which is helping to speed up the reaction. So that is how we can make our chemical equation more informative by mentioning the conditions of the reaction on the arrow. Now point number 2, mentioning the colors and the state of the reactants and the product. If needed, the colors and the states of the reactants and products are written within the small brackets below their names. So while we talk of any of the chemical reaction, we can mention the color and the state of the reactant and the product. Like here in the example, copper sulfate pentahydrate, it decomposes to give copper sulfate and water. So here copper sulfate, a reactant, it is blue in color. Okay, so that is the color of the reactant. And what is the state? It is crystalline in nature. After the reaction has been occurred, it gives copper sulfate, a product that is white and powdery in nature. Remember, white is a color and powder is a state. And it gives water in the vapor state. So that is how we can make our equation more informative by mentioning the color and state of the reactant and product. Let us move further. So point number 3, indicating a gaseous product and a precipitate. A gaseous product can be indicated by an upward arrow and a precipitate by a downward arrow. So while looking onto the chemical reaction, if it is having an upward arrow, we should understand that it represents a gas. And if it has a downward arrow, we should understand that it represents a precipitate. Now, what is a precipitate? It is a solid that separates when a solution is added to the another. Okay, so definition you should remember. A solid that separates when solution is added to another, it's a precipitate, and it is indicated by a downward arrow in any of the chemical reaction. Atoms rearrange themselves in a chemical change. Why are new substances formed in a chemical change? We know that we start with reactant and product is a new substance that is formed after the chemical reaction has been occurred. Now, why are these substances formed? Because the atoms, they rearrange themselves in such a change. In any of the chemical reaction, the atoms rearrange themselves. Here I have shown in the picture that we have hydrogen atoms and we have oxygen atoms. While they occur in a chemical reaction, while they react with each other, the product is water. Okay, so you can see that we have hydrogen atom, they are represented by blue, and oxygen atoms, they are represented by red, and they rearrange to form water. They have taken a new position. Okay, so that is high. Again, the atoms contained in the molecules of hydrogen and oxygen, they rearrange themselves. We will find that the number of atoms of each element remains same even after the reaction. Even after the reaction has been occurred, so the number of hydrogen atoms before the reaction, they were 4. So even after the reaction in the product, the number of hydrogen atoms are 4, and number of oxygen atom before were 2, and after the reaction they are also 2 in number. So that is how the number of the number of the atom of each of the element remains same in a chemical reaction. Now let us move to the next topic, energy changes in a chemical reaction. Now, we have already studied since the atoms rearrange themselves in a chemical reaction, we can understand that a reaction involves the breaking of the reactant molecules and the making of the product molecules. Since we know that the reactant and product are the main important things in a chemical reaction. So either it involves breaking the reactant molecules are broken, or it involves making of the product molecules. So in both the steps, the energy that is involved, that is not equal. So either we require energy or the reaction absorbs energy. Okay. It releases energy, requires or absorbs one and the same thing, or it releases energy. In most of the cases, the energy absorbed or given out is in the form of the heat. However, in many cases, light is also absorbed or given out. So this energy change that we are talking of in a chemical reaction, that occurs mostly in the form of heat. But in some of the reactions, light is also absorbed or given out. So either any of the reaction, it may need some energy, it may need some heat for its occurrence, or after the reaction has been occurred, there could be a release of energy. Now let us study more about this. Endothermic reactions, a reaction in which the heat is absorbed. It is called as the endothermic reaction. Endo means in. That means the energy is required for the reaction. It is absorbed. For example, nitrogen plus oxygen give nitric oxide. So in that we need electric spark. Okay, so the energy is required in the form of light or heat. So an endothermic reactions takes place only till the reactants are provided with the required energy. So until and unless we don't have that much energy to initiate that reaction, the reaction is not going to begin. So there should be a sufficient amount of energy that should be required for any of the reaction to occur. So if that energy or that compensation is not made, the reaction is not going to start. So in endothermic reaction, the heat is required or the light is required. It takes place only the required energy is provided. The reaction stops the moment the energy supply is cut off. So as soon as we cut off the supply of energy, the reaction stops. It cannot continue. Moving to next category, we have exothermic reactions. A reaction in which heat is evolved or given out is called an exothermic reaction. Most of the chemical reactions are exothermic in nature. Remember that. Okay, so a reaction exo means out. Hydrogen, for example, hydrogen plus oxygen, it gives water and it releases heat. That is an example of exothermic reaction. Remember, unlike an endothermic reaction, an exothermic reaction once begun always reaches its completion. As much heat is evolved as required for the reaction to go on. Thus, once it starts, burning continues on its own. So, once you have initiated the exothermic reaction, it continues to go on until it reaches its completion point. While that is not the case in case of endothermic reaction. While exothermic reaction, it can continue of its own once it has been initiated at least to the completion point. Okay. Now let us move to characteristics of the chemical reaction. Several characteristic changes accompany a chemical reaction. In many cases, you can guess what has happened by observing these changes. So there are certain things which help us to identify what are the changes that have been occurred in any of the chemical reaction. With that, first is change in color. A change in the color of a substance generally suggests that a chemical reaction has taken place. Okay, so a change in the color of the substance, suppose we have already discussed one of the example. There could be change in any of the color of the substance even. So that indicates that the chemical reaction has been occurred. For example, here, when heated, copper carbonate that was green in color originally, it turns black due to the formation of the copper second oxide and carbon dioxide. So earlier the color was green of the reactant. After it has been changed into a product, that is a new substance, it changes into black. Similarly, when dissolved in dilute sulfuric acid, iron nails which are grey in color, it gives a light green solution of iron sulfate. Again, the color of the iron nail from grey has been changed to light green on dissolving in dilute sulfuric acid. That means it has reacted with it, and that is why the color of the iron sulfate has been changed, and that is why we can say that the chemical reaction has been occurred. Now let us move further, that is the evolution of the gas. That is the second most important characteristic of any of the chemical reaction. Gases evolve in many chemical reactions. Some gases have a characteristic odor and can easily be identified. You know that we already know that some of the things they are special. While our mother, she is cooking the food at home in kitchen, you can identify some of the people, they have great sense of smelling, right? So they can easily identify, right? They can easily identify that what their mother is actually cooking by just smelling the fragrance of that particular food, right? So similarly, some of the gases, they also have a they have a characteristic odor and they can be easily identified by their smell. For example, ammonia has a pungent smell. It's a kind of bad odor. You can just just smelling that, we can easily identify that the gas involved is ammonia. It has a different kind of smell. And similarly, hydrogen sulfide, it has a pungent smell and it has a smell of rotten eggs. Rotten eggs, you already know, जो सड़ जाते, right? Okay, if it get it has a bad smell. It has a kind of bad smell. These are the chemical tests for the different gases. Okay, so that was about smell. Similarly, we can also identify certain gases based on their taste, right? Like we have studied even in class 6, that carbon dioxide, it turns lime water milky. Okay, and hydrogen, when ignited, it burns with a pop sound. So we can identify if the lime water is turning milky, we can easily guess that the gas involved is carbon dioxide. And hydrogen, when ignited, it burns with a pop sound. That we can just identify that the gas involved is hydrogen in nature.